There is a question that's posed in my math lab about annuities. So that's what this particular video addresses. So first of all, in the problem that's given, you're asked to find the value of an ordinary annuity at the end of the indicated time period. And you're told the payment R, the frequency of deposits is M, same thing as frequency of compounding. The annual interest rate is a lowercase r, and the time t are all given. So in this particular problem, we know the value of r, I'll just jot it down over here, that r is 300. We also know the frequency of deposits, that's the value of m, is 12. This is done on a monthly basis. So that means this is a savings account that's not only earning interest, but you're making deposits every month, not just a one-time deposit. The annual interest rate, lowercase r, is given as 3%, so we're going to use 0.03, writing it as a decimal. And then the time here that we're given in years is 4 years. Now, to work with that time period, we need to go back and look at our formula here for finding the future value of an ordinary annuity. And what you'll notice is that assuming that we're making regular payments into an ordinary annuity that's being compounded m times a year, the deposits are made at the end of each compounding period, the future amount A of this annuity at the end of n periods. So n in this formula is the number of periods over the entire time. So in our problem up here, n is going to be equal to 4 years, and we're making deposits 12 times a year. So our value for n, the number of times we've made deposits, is 48 times. And the rest of this is a matter of substituting into the formula. Okay, so we're going to make some replacements into this formula down here. So we've got A, that's what we're looking for, equals 300. That's our value of R, our monthly deposit. And then in parentheses, we have 1 plus our rate, 0.03, over the number of times compounded, which in this case is 12, it's done monthly. And we're going to raise that to the 48th power. That's our n, 48. Subtract 1. All that's the numerator, and our denominator is 0.03 divided by 12. So the rest of this, to solve this, is a matter of plugging this into our calculator. Now, sometimes students have a little bit of trouble with that, so I'm going to write down how it may look on your calculator screen when you type this in. What I would do is treat the, we've got 300 times this fraction here, okay? And within this fraction, we have a numerator and denominator. So I'm going to put a big parentheses around all of this, and then another parentheses just for the numerator. And the numerator is this 1 plus 0.03 divided by 12, all raised to the 48th power, minus 1. And then I'm going to close that off. That's my numerator. That's the top part of all of this. Let's see if I can highlight that. That's this stuff right here. I'm putting them in this set of parentheses. And then what I want to do is take that and divide it by, and my denominator I'm going to put in parentheses. That's going to be 0.03 divided by 12. I'm going to have to go down here to my next line. Divided by 12. Close that parenthesis. And that's going to take care of everything in the denominator. Let's do a little different color here. That's this stuff. That's all in parentheses. And then we want to finish it up by saying all of this big fraction here. So we've got to put another parenthesis. So this big fraction here, or big parentheses for the fraction. Anyway, when we type all this into our calculator, our answer is $15,279.36. Okay. You just need to be very careful punching this into your calculator. And that value of n that I talked about up here for the exponent, that needs to be the number times compounded times the number of years. So that's where we're getting 48. I hope this helps.